Okay, so this is FRQ number 4. So the question asks a 10 kilogram block sits on a horizontal surface with a coefficient of friction of 0.2 between the block and the surface. A string runs from the block over a wheel of radius 10 centimeters and a moment of inertia of 2. Off the bat, we know our moment of inertia is going to be 2. Let's just write that down first. Find the acceleration of the mass. So first, what I'm thinking, I'm gonna set up newtons to isolate for the tension. So we have TL and TR. So if you look for this system right here, for the 10 kilogram block, the force pulling it, it's going to be tension L. And it says this is a rough surface, so what's going to be holding it back is the friction. So if we write TL minus F of K equals the mass, the 10 kilogram, and the acceleration. So let's isolate for TL by itself. TL is equal to F of K plus M10 of A. So let's expand out what FK is. Force of friction is just normal force times mu K. Normal force, because as you can see, this block right here, it's not on a slope or anything, so it's just going to be equal to F of G, which is also M of 10 G mu K equal to TL plus M10 of A. So this is what your tension L is. Let me move it up a little bit. So let's find out what our tension R is. If you can see for TR right here, what's pulling it down is your F of G, and what's keeping it going against that is your T. So let's do M of 5G minus your TR. Let me do capital R equals your M of 5A. And then we're just going to isolate for your TR. So TR is going to equal to your M5G minus your M5A, because you end up subtracting that over. So now that we have these two, let's set up torque. So torque, we're going to set up by having TR, because that's the one pulling down. It's going this way, so might as well have it in the front. Tension TR, you have to times it by the radius of the wheel right there. Subtract from TL times also the radius of the wheel. Is going to be equal to I alpha. So that's what we have right there. So then let's just substitute that in for that and this in for that. So that's going to be M of 10 G mu K plus M of 10 of A. That's all going to have an R right here. And then same thing for T of L. Oh no, I subbed in the wrong one. So TR, it's actually this one. So it's going to be M of 5G minus M of 5A, my bad, R. Sub in here, TL, M of 10G mu K plus M of 10A. And then there's also going to be an R there. And then that's going to equal to, so we don't have to expand out the I because I already told you what the value is, which is 2 up here. So I'm just going to do 2, and then we know that A tangential is equal to alpha or alpha. So if we have an alpha there, just isolate for that. That's going to be A over R, which is equal to alpha. So that's going to be 2A over R. Alright, so let's distribute the R in. We're going to have M5 of GR minus M5 of AR minus, remember to distribute the negative sign too, M10G mu KR minus M10 AR. That's gonna equal to 2A over R. So at this point, let's just start plugging in numbers. So let's see. So you know your R, it said it was 10 centimeters. 2 divided by 0.1. So that's, I don't even know why I use a calculator for that. 20A equal to, we have your mass for, let's start from left to right. So 5 times 9.8 times 0.1. That equals 4.9. Alright, so mass is 5 times R. That would just equal to minus 0.5A. Your 10 right there, so that's mass of 10 times 9.8. And your mu K is 0.2. That was given. Times 0.2 times your radius, which is R. That gives you minus 1.96. And then that's just 10 times 0.1, which is 1. And then that equals to 28. Let's see if you can see what's happening. So let's just add all the common stuff together. 4.9 minus 1.96 equals 2.94 equals, we're gonna add all the stuff with the A's to the right side. So that's 20, 20.5, 21.5 A. So your A is equal to 2.94 divided by 21.5. 0.1367. That's your A, so meters per second squared. Alright, next up, part B, it's asking for angular acceleration. So you have your A tangential, which is just equal to your radius times your alpha. We're trying to find angular acceleration, so that would be your alpha. So if you isolate for that, my bad, it would be alpha is equal to A tangential over R. You know your R is equal to 0.1. A tangential is 0.1367. So you just end up moving the decimal over, so you get 1.367. Don't forget your units, probably rads per second squared. Check the time. I'm probably gonna need to move over to this side. Clean page. So is it still recording? Yes. So find the tension of the string. So all we have to do back is just plug in. So we solved our tension right here. This is what our tension is. So all we have to end up doing is plug in our A, which we found down here. You should get your tension. So let me just copy that over real quick. TL, blah, 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 blah. So your TL is going to be equal to, what is it, M10G mu K, M10G mu K, M10G of mu K, and it was plus M10 of A, and then your TR would be equal to M5G minus M5A. M5G minus M5 of A. So we already know all of this stuff, so it's just all plugging in. So your mass is 10 times 9.8 times your mu, which is 0.2. That gives you 19.6 plus, let me just make sure I wrote everything down right, plus 10, which is your mass, and your acceleration was times 0.137, 1.37, so you add that, 19.6 plus 1.37, 20.97 newtons is your tension for TL, and for this, your mass is 5 times 9.8. roughly almost 50. 49 minus 5, which is your mass, times 0.137. That becomes 0.685 if you just subtract those. Insert, subtract. 48.315 newtons. That is your tension for R, and that should be all of the parts.